Can we start the class? So, welcome guys, welcome to NEET World. So, in last class what we have seen? Integration and differentiation we have seen, right. So, in this class we will deal with graphs. We will start with graphs now. So, what is basically graph? Like how we will draw the graph first? X axis will be there and y axis will be there, okay. Basically we will say some x component and y axis, x and y axis is there, okay. Now how we can draw the x and y axis? How we can represent that? Like if I am drawing some line like this, how we will draw that line? Some equation will be given like y is equals to 2x, okay. Some equation should be there. If I take the value of x equals to 0, I will get y equals to 0, x equals to 1, y equals to 2, x equals to 2, y equals to 4, x equals to 3, y equals to 6. I will get these values. Suppose for example x equals to minus 1, y equals to minus 2, x equals to minus 2, y equals to minus 4. I will get some values. Now these values, if I take the x axis and y axis, if I place them in the graph, I will get some kind of image, no, I can get some kind of image there, right, no. So which means one should be dependent and another should be independent, right, no, one should be dependent, another should be independent of that. So from this, which one is dependent is x is dependent, x axis is dependent axis, y axis is independent axis, okay. Yeah, graph in physics. So graphs are visual tools to understand how one quantity change with another, right. No, if x changes, obviously y changes, right, yes or no. In the previous case we have seen x equals to 0, y was 0, x equals to 1, y was 2. Like if x keeps on changing, y also keeps on changing. Then in physics we often relate time with position and velocity, accelerating pressure. Like if I take like position and velocity, or velocity time graph I will take, okay, velocity time graph. So velocity should be independent quantity, time should be dependent quantity, okay. So example, plotting distance versus time helps identify if motion is uniform or non-uniform, okay. So uniform motion means what we have seen? Uniform motion, it is constant. Non-uniform means it is not constant with respect to time, constant with respect to time it is uniform, okay. So coordinate axis, x axis horizontal and usually represent the independent, independent quantity, y axis is dependent quantity. I have said ulta, no. So y axis is dependent quantity, x axis is independent quantity, okay. So the position 0, 0 is called as origin. An example, in a speed time graph, time is on x axis, speed on y axis. This is what we have discussed, like velocity in y axis, time is in x axis. So one thing that is like independent is x axis, dependent is y axis, okay. Yeah, the slope of a line is a tangent of the angle made by the line with the positive x axis in the anti-clockwise directions. It tells us the rate of change of like how much the graph has been changing. Like if we want to know what is slope, like slope in simple word we can say it is a tan theta. So tan theta means nothing but opposite by hypotenuse. So if I take this is my graph, okay, if I take this point, if I want to draw the tangent like this, okay, tangent like this. So this is my x axis, this is my y axis, so opposite by adjacent, so should be equals to y by x, okay. So slope, simply you can close your eyes and say tan theta is equals to y by x, And one more thing, where 0, I mean theta will be 0, less than 0 and greater than 0 and less than 180 degree. So in this we need to understand whether theta is increasing or decreasing, which means slope is increasing or decreasing. Okay, the main concept is whether slope is increasing or decreasing. So slope is increasing or decreasing means like speed is increasing, speed is decreasing, it is getting accelerated, it is getting decelerated, we can say. Okay. Yeah. So theta will be like between 0 to 90 means slope is positive. Then 90 to 180 slope is negative. 0 or 180 slope is 0. And exactly 90 means not defined. So now we have seen the trigonometries, right? Sin theta, cos theta, tan theta. In the trigonometries, sin and tan values are increasing, but whereas cos values are decreasing in terms of 0 to 90 degree, right? No. So tan theta, tan 90, 0 to 90 slope is positive, understood? And 90 to 180 again it is decreasing, it is negative. What is tan 0? 0 by 1, cos by sin by cos na 0. Tan 180 0, infinity. 90 no, 90 is undefined na? Yes. So 90 exactly it is not defined, it is infinity, right? No, it is infinity. So this is the main concept you should keep in mind whenever you are dealing with the slopes. 0 to 90 positive, 90 to 180 negative, exactly 180 or 0 it is 0, and which means 90 not defined. So 90 in the case it is perpendicular direction. 0 or 180 means exactly like this, exactly in horizontal, like parallel to horizontal. If I am drawing a line or drawing a tangent, suppose in this case I am taking a curve like this, okay, curve like this. If I take this point, for example I am drawing the tangent like this, so in this case slope is 0. Yes, no, like or parallel to that. Parallel means 0, perpendicular means it is undefined, will say. Okay, undefined will say. That's what, no, 90 degree. We should see this angle with respect to this. If I take with respect to the x-axis, no, angle 0. Here it is 90 degree. So if I take a point here, if I draw this and if I see the angle is less than 90, no, less than 90, acute and obtuse angle will say no. Yes, no. So less than 90 means positive. So if I take a line here, over here, I draw a tangent like this. So angle is greater than 90, which is negative. Okay. Yeah. For theta equals to 60, tan theta will be root 3, which is positive slope. Same theta equals to 135, tan 135. I can write 180 minus 45. No, I have told whenever we are getting the 180 value, I should write the same tan theta only. If it is 90 or 270, tan will be changed to cot. So it is minus 45. No, 180 minus 45, tan 45. So 180, which quadrant? 180 minus theta. Second quadrant, right? Second quadrant, tan is negative. So minus tan 45. It is minus 1, negative slope. Okay. Any doubts in this? Okay. Yeah, we'll go for next one. Okay, slope using dy by dx. So suppose an equation is given, f of x, some function is given with respect to like 3t square plus 2t. Okay, if any equation is given and they are asking for the slope, Okay, simply what I should do is differentiate this one. So here they given no y equals to 4x plus 7. What is the slope of that equation they are asking? Okay, what is the slope of that equation? If we differentiate that one, we will get 4, which is constant slope. Constant slope. Okay, suppose if I am getting some other value like 4x, which means it is a variable slope. If x, if I put 0, 0, 1, 4, 2, 8, 3, 12. Right now 4x if I keep, the answer will be changes, which means it is a non-constant slope. Here I am getting a constant slope. Done. So same here, if I do the differentiation, what I will get? 60 plus 2, which means it's a not constant slope. No, it is variable slope. Slope, right? Na? Next, if y equals to 2x square, then dy by dx equals to 4x, variable slope depending on x. Any doubts in this? So two cases, one case is constant, another case is variable. So types of slope in graph. Positive slope, line raises from left to right. Left to right in the sense, here we have seen, no. So from left to right it is raising. So again line falls from left to right, which means here it is negative, no. It is positive angle, acute angle, it is obtuse angle. So it is falling from left to right. It is raising from left to right. So when a line raises or a tangent raises from left to right, it is a positive. Falling from left to right, it is a negative. Yeah. So horizontal line, 0 slope. Like horizontal line, 0 slope. Vertical line, infinite slope. So this is the line. If I draw like this, positive. If I draw like this, negative. If I draw like this, means the angle is there, no, it is less than 90. If I draw like this, the angle with respect to x axis greater than 90. Okay. Yeah, this is the thing. So here it is a positive slope, rising, no, and it is a negative slope, it is a falling. So horizontal and vertical, undefined or infinite, or with respect to 0. Yeah. Any doubts in this? So graph has been completed. We will move with the vectors and scalars now. Okay, the basic graph has been completed. If you are having any doubt, you can ask me. Okay. Right on the next topic, vectors and scalars. Vectors and scalars. Okay. So the main difference between vectors and scalars is like vectors is a having both magnitude and direction, having both magnitude and direction. Scalar is only magnitude, no direction. Okay, this is the main difference between vectors and scalars. Okay, so first point, any physical quantity is either a scalar or vector. Physical quantity means Any physical quantity? If we take like if we measure some apples are there, okay, which means in numbers we'll measure, right? Now if I am going in some directions, we'll measure the length of that direction, right? Now like I am going in 2 kilometers from north to east direction, right? Now so if I measure the length with respect to direction, it's a vector. Only number means it's a scalar quantity. So the next point, like scalar quantity is described only its magnitude and obeys the ordinary algebra rule, which is addition, subtraction, multiplication and division. And if any physical quantity has both magnitude and direction, it's a vector. So example, if you see, mass, volume, distance, speed are the scalar, whereas displacement, velocity, acceleration, weight, gravity are vector. So the main difference between the mass and the weight are, weight depends upon the gravity, but mass doesn't depends upon the gravity. Okay. So the current has direction, but it does not follow the vector quantity. See, if I take current now, 2 wires are there. Okay, 2 wires are there. One wire is giving 2 ampere, 2 wire is giving 3 ampere. If I connect both wire, if I take the single wire now, total ampere is 5. 2 plus 5, so 2 plus 3 is 5. Right now, in this cases, like one is coming from, one is coming from left to right, 2 ampere, and one is coming from right to left, 3 ampere. I am taking everything from top to down, which is 5 ampere. Here the directions are there, but when I am dealing with the currents, we won't follow the vector rules. Only the scalar applicable here. Okay, only scalar is applicable. You can take down now. Bhavesh. Hello, man, Bhavesh. Okay. We go for the next thing. Done. Devi. Okay. Completed. Done. So general points regarding vector. So usually we write in a bold letters. Okay. Bold letter in the sense capital letters, na. So if I write a vector A, it should be written in capital letters, or B, capital B, C, capital C, capital D, like that. Okay. The second point is vector is shown by an arrow, okay, which is the direction from left to right. So this is my vector A, vector B, vector C, vector D. Okay. And the fourth point is length of the arrow gives the magnitude. Tail is the starting point, head is the ending point. So in this, which is tail? This is the tail point, no? Tail point, and this is the head point. Yes, no? Tail and head point. Have you seen the archery? Yes, no? Archery. So the end point will give the tail. Head point is the starting point, right? No? So we'll see the types of vectors now. Okay. So there are many types of vector. We'll see what is first one is unit vector. So unit vector means magnitude is 1. Unit magnitude. Okay, unit magnitude. So the formula to find the unit vector is a cap is equals to a by modulus of a. I will give you example here. Suppose a vector is given as 2i plus 3j. Okay, 2i plus 3j. I need to find what is the unit vector of this. Okay, unit vector of this. So simply I can write the formula. A cap is equals to 2i cap plus 3j cap divide by, so modulus of a, no, modulus of a is nothing but under root of 2 square plus 3 square. Whatever the number is there, take it under root. Okay, modulus of a, which is nothing but 2i cap plus 3j cap. What is the answer for this? 4 plus 9. Root 13. Root 13, no? So 2i cap by root 13 plus 3j cap by root 13. So remember the formula. A cap is equals to a by modulus of a. Take down the formula. And unit vector along x, y, z is I cap, j cap and k cap. Okay. So x axis I cap, y axis j cap, z axis k cap. Okay. Next, 0 or null vector. 0 or null vector, the name itself says that the magnitude will be 0. Like vector has a 0 magnitude, no specific direction. So position vector of origin is 0 vector. Okay. So which means 0 comma 0 comma 0. X, y, z, no, 0 0 0. Okay. Which one? For which one? Null vector 0 comma 0 comma 0, no? Yeah. Which one? It's a vector, unit vector will denote. I cap, j cap, k cap.
Only unit vector?
Yes, no, like vectors itself, like when we are denoting with I, j, k, will denote with caps. Done? So equal vector. So the name itself says equal vector means same. Like if I take A and B, both are having equal. So if we consider two vectors and if their magnitudes are equal, so suppose I cap is there, A is equals to some I cap, B is equals to some I cap. Okay. So magnitude means the numbers, no, the number should be same. If I write the number 5, this also should be 5. So 5i, 5i. Equal magnitude means equal vector. Parallel vector, when both vector has same direction means here we have seen, no, I, j, k. I means x direction, j means y direction, k means z direction. In this case, if I write A is equals to 3i cap, B is equals to 7i cap, is both are parallel vector? Yes, because both are in the same direction, x axis. I cap and I cap only, no, both are having same direction, which means parallel vector. But these are equal vector? No. So the second point is equal vector are always parallel, but parallel vector may not be equal, right? No, that's the point. Here this is parallel vector only, parallel vector, but I can't say it's an equal vector. But in this case, it's an equal vector as well as the parallel vector. Both are in the same direction. Any doubts in this? So anti-parallel vector. Anti-parallel means opposite direction. So if I take A equals to 3i, or suppose B is equals to minus 3i minus 7i. Understood? Opposite direction. One is in this direction, one more is in this direction. Anti-parallel. Understood? Negative vector has equal magnitude but in opposite direction. Equal vector means we have seen both are in the same direction, equal magnitude, right? So we have seen that A is equals to 5i cap, B is equals to 5j cap. No, this is equal vector. Suppose if I write A equals to 5i cap, B is equals to minus 5i cap, which means equal only but in opposite direction. So negative vector we will say. Okay, negative vector, like equal magnitude in opposite direction. So if it is not equal but in opposite direction, what we will say? Anti-parallel, right? No, anti-parallel. So concurrent vector means co-initial, okay, co-initial, which means same initial point, will say same initial point. Suppose if I take a vector from this point, it's starting like this, so some other vector also starting from the same point. If I take the third vector, same point. It may be and may not be. Okay, have you seen this Bahubali, no? That Prabhas will used to keep the 3 arrows and he used to give, no? Yes or no? So both are, I mean 3 are starting at the same initial point and going somewhere else. Yes or no? Going somewhere else. So coplanar vector. So like vectors lies in the same plane. Same plane. Understood? Same plane in the sense if I take only x and y axis, or y and z axis, or else z and x axis. Okay. Next, orthogonal vector. Both vector in the 90 degree. Like when both vector makes an angle 90 degree between them. So if I take a vector A like this, vector V should be makes an angle 90 degree with respect to vector A. That is orthogonal vector. Any doubts here? It can be or cannot be. Like if I take this, it is going in from left to right. If I take this one, going from with respect to northeast direction, it is exactly east direction. It is southeast direction, right? No. So multiplication and division of vector by scalars. Okay. So now if I take a vector A, I cap is there. If I multiply with 2, it will become 2 I cap. So one is vector. I cap is a vector, no? If I multiply with 2, 2 is a scalar, it's only as magnitude, no direction. I means denotes it is in x axis. 2, it's no direction, only number is there. So if I multiply 2 with that I cap, it will become 2 I cap. So magnitude times the vector it will come. Okay. So here vector A multiply with the scalar m, it will become vector ma. So multiplied by the magnitude times. Okay. So magnitude become m times the original, that's the meaning. So direction depends upon the sign of the scalar. If I multiply minus 2, minus 2i, right? No. So properties, m1 plus m2 of A will be equal to m1a plus m2a, or m into a plus b equals to ma plus mb. So this A is there, no? A and B are both are vectors. Okay. m1 and m2 are magnitudes, scalar. So addition and subtraction of vectors. So vector addition involves combining 2 or more vectors. If I want to add, there should be 2 or more, no? If I take only one, can I add anything? No. If I have one more thing, I can add both of them. So the result is a new vector called a resultant vector. So in this 2 types are there. One is triangle law, one is parallelogram law, like methods. Okay. So parallelogram law, first we will see what is parallelogram law. So used when 2 vector acts from a common point. So common point in the sense we have seen the co-initial point, start from same points. Yes or no? Co-initial. Co-planar means same plane. Co-initial means same point. If 2 vectors having same initial point, this is vector A, this is head, tail, no? This is head. So this is A vector. If I take the B vector like this, so this is B vector, this is head. If I draw exactly parallelogram, no, I'll get like this. So from this point, tail point to other end, the diagonal, no, this is the resultant, we will say. Okay. So construct a parallelogram with the vector as adjacent side. So these are the adjacent sides, no. So the diagonal from the common point represent the resultant vector. So this is the diagonal, no. This is the diagonal from the common point, gives the resultant vector. Okay. So triangle law of vector. Triangle law of vector. In this vector, what is the main thing is, one vector is there, I should place the another vector head of the first vector. So suppose this is my vector A. So previous case I have placed in this manner from the tail of the vector A. But if I want to take the triangle law, I should place like this. First vector, second vector is the head of the first vector. If I take third one, third vector should be place of the, head of the second vector. Fourth vector, head of the third vector. Okay, I keep on join that. So when I take more than two vector, we'll call as a polygon. Triangle means only 3, no? So 3. So the resultant will be from this point to this point. This is A vector, B vector. So resultant from tail of the first vector, head of the second vector will give the resultant vector. Okay. Now we will see the formula for the parallelogram, which is nothing but R is equals to under root of A square plus B square plus 2AB cos theta. Okay. So cos values, if you substitute cos 0, 1, 90, 0, 180, minus 1. Keep in mind cos 180 minus 1. Now the vector subtraction. So vector subtraction, like addition we have done, no? Addition we have done. So resultant equals to A plus B is the addition one. So vector, like subtraction one means I am subtracting the two vectors. Here B is negative. R is equals to A plus minus B. Okay, minus B. So what is the formula? R is equals to under root of A square plus B square minus 2AB cos theta. Okay, there it is plus, here it is minus. Okay, only the vector, like I am taking in the opposite direction, that's it. Okay, here minus B square, no, minus B square will become obviously plus only. Yes, no? So plus 2A into minus B, so minus came. Done. So you can take this formula. So subtracting a vector is equivalent to adding its negative. Adding its negative. Change the direction of the vector to be subtracted and apply vector addition rule. Example triangle method also we can use. Okay.
So any formula for triangle?
Triangle, if I take like mostly will take from east, like west to east direction, again east to north direction. Suppose okay, a particle is traveling from west to east direction, suddenly it turns from south to north direction, which means like this, no? Yes or no? So this is vector A, this is vector B. Find the resultant vector they are asking. So obviously we will use this. Okay, depends upon the question, I can use either triangle or parallelogram. Okay. So next, what is polygon law of vector addition? So when we take the more than two vectors, no, we have talked about parallelogram and triangle. In those we have talked about only two vectors. But when we talk about more than two vectors, we'll call it as a polygon law of vector addition or subtraction. Okay. So in this case, what we will do, if I take consider three vectors that is A, B, C. Okay, A, B, C are there. So the procedure is keep the first vector as it is. However you want, you can keep. A vector is there. Second vector should be starting from the head of the first vector. So I should start like this. This is B vector. Third vector should be head of the second vector. So this is my third vector. So resultant vector should be tail of the first vector, head of the last vector, not second vector, third vector, last vector will say. Okay. So this is my resultant vector, no? Resultant vector. Okay. So now you see, used to add three or more vector acting in a sequence. Place vector head to tail, one after the another. The resultant vector is drawn from the tail of the first to the head of the last vector. That's the thing we have done, no? Like A, B, C. So from A to C, I have drawn the resultant. Okay. Now if I draw the equilibrium condition, no, like this is my A, this is my B, C. If I draw C, D, like resultant like this, is there anything? 0. 0 only, no? I am coming to the same point. It's 0. So resultant should be like in the opposite direction. If I draw this 3 in one direction, resultant is coming from the opposite direction. Okay. Now, condition and applications. All vector must be placed in a specific order, that is head to tail. Second is resultant vector completes the polygon from start to the end point. So this is my starting point and this is my ending point, no, right? So common in force system, displacement or velocities. Okay, you have understood three types, no? One is triangle law, second one is parallelogram law, the polygon law, which is having more than two vectors. Okay. So one more formula we have seen, that is R is equals to under root of a square plus b square plus 2ab cos theta. If it is negative, a square plus b square minus 2ab cos theta. Okay. So one more thing, parallel means both are in the same direction, we can add it. Okay. Parallel direction adding the vector, anti-parallel direction subtracting the vector. Okay. If any question is there, like they have not mentioned adding the vectors, two vectors are in same direction, give the resultant vector they are asking, which means adding the vector. Right now two vectors are there which are in the anti-parallel direction, I should subtract the vector. Okay, done. Special cases, equilibrium condition. If the polygon is closest, like that is resultant is 0. Right now the system is said to be in equilibrium, net force or displacement becomes 0. I am coming to the same point na. Same point. Displacement is nothing but it's the shortest point. Whether I am traveling from this point to A point to B point, some distance will be there. If I come from B to A again, what is the displacement means? 0. If I start and end at the same point, displacement is 0, but distance will not be 0. I have travelled somewhere. Right now? Now, net for like useful in statica, balancing the problems. This balancing the problems we will see in laws of motion. Right, laws of motion, like balancing the equations, balancing the problems, equilibrium conditions we will see. Okay. Now two vectors A equals to 4 units east and B equals to 3 units north are added using triangle law. Find the magnitude and direction of the resultant vector. Okay, so now if I take 4 units in east, no, this is my 4 units in east, A vector, okay, 4, and B north, no, what will be the resultant? Should I draw like this or like this? From this point to this point, no, this is my resultant. So what is this? 3. So what is the angle made between them? 90 degree. Can I use the Pythagoras theorem? Yes. A square plus b square. R square equals to a square plus b square, which is nothing but a square is 4 square, b square is 3 square, 16 plus 9, which is in under root, which is nothing but 5 units, na? 5 units from northeast direction. Northeast direction. If I take the same thing, if I want to draw, if I want to get in parallelogram law, a square plus b square plus 2ab cos theta, cos 90, 1 na, 0, no? Am I getting the same answer? Done. So this is the second question. Give answer for this question. We'll see. Two vectors of magnitude 5 Newton and 12 Newton acts at a point with an angle 90 degree between them. Previous case we have seen that one is east, one is north. Angle between them is 90 degree. Here they have not mentioned the directions, they have mentioned the angles now. Find the resultant vector they are asking. So what I should do is, right now, this is my 5 units, this is my 12 units. Angle between them, no, angle between them. So both are starting from the same point, parallelogram law. Right now, so this is my resultant. I am extending the parallelogram, parallel lines. Okay, so this is my resultant. Angle theta equals to 90 degree. So R will be equals to under root of a square plus b square plus 2ab cos theta. So what is a? 5. 25, no? B square 144 plus 2 into 5 into 12 into cos 90, 0. So this total term will become 0. And this one 144 plus 25 169. Root 169 is 13 units. Right? No? 13 units. Done. Any doubts in this? So the next question, vector A equals to 6i cap plus 8j cap, vector B equals to 4i cap plus 3j cap. Find A minus B. So find A minus B means I cap separately, j cap I am separating separately. So 6i minus 4j. So A minus B equals to 2i. Next 8j minus 3j plus 5j. So the next part of the question I am saying is find the unit vector for A minus B. Unit vector, what I should do? A minus B by under root of
A square, 2 square, plus 5 square.
like this is my A minus B, no, like this is my unit vector, should be equals to A minus B by modulus of A minus B. Okay, let me take wait, A minus B, like C equals to A minus B. Okay, C equals to A minus B. So unit vector C cap equals to C by modulus of C. Right now, so what is C? 2i plus 5j. 2i plus 5j divided by under root of 4 plus 25, which is equals to 2i by root 29. Right now, root 29 plus 5j by root 29. These are my unit vectors. So here they can ask A minus B and find the unit vector, or A plus B or find the unit vector. Any doubts here? Can you do A plus B and unit vector? A plus B and unit vector.
10i plus 11j by
Now what I should do? 10i, no?
Yes.
10i plus 11j. 10i plus 11j. So C will be equals to 10i plus 11j. So C cap will be equals to 10i plus 11j divided by under root of 100 plus 121. So 10i by root of 221 plus 11j by root of 221. Any doubts in this? So unit vector formula you know. Whatever the vector is given, keep as it is by modulus of the vector. Okay. The next question, two equal vectors of 10 units each acts in the opposite direction. What is the resultant vector? What I said, anti-parallel means opposite direction. Angle will be 180 degree. Same parallel means angle is 0 degree. Okay, keep in mind parallel addition, anti-parallel subtraction, anti 180.
0.
Okay, done. Any doubts in this? Any doubt in this question?
Sir, cos 180
Minus 1. Okay,
The answer is resultant is 0.
find it.
Find it. 2 vectors.
Two vectors, equal vectors, no?
Equal opposite in direction.
Opposite in direction. A square plus B square minus 2AB. 2 times of AB. 100 plus 100 minus
2 into
minus no minus 2 into
AB.
AB of minus 1, no? Minus 1 will come, no? Minus of minus. Right, na? Anti-parallel. Angle is 180 degree. Both are in the opposite direction. Done, no? So if I take this one, angle is 0. Both are in the same direction. Positive, positive. I told, like keep in mind, this is positive direction, this is negative direction. A is positive, B is in negative. Okay, B is in negative. Angle between them is 180 degree. Okay. So A square, like minus A if I take, minus A square means A only will come. B minus B if I take, minus positive will come. Either if I take any one of them, A square or B square will be positive. But 2 into minus A or minus B if I take, minus 2AB will come, no? Minus 2AB cos theta. Cos 180 minus 1. Done? 200 100 plus 100 minus 2 into 10 plus 10 into 10 minus 1 again, cos 180 no.
So plus
Yeah.
under root 300.
Okay. Now displacement, it's a vector quantity. Velocity vector, speed scalar, acceleration vector, position vector, project like. Now we will see the projectile motion like relative velocity graph analysis. So if I talk about the projectile motion now, which is in the motion in a plane, relative velocity motion in a plane. So if you are well enough confident in the vector no, it is easy to tackle the projectile and relative. Okay. So a vector quantity as magnitude and direction, displacement. Vector defined as the rate of change of displacement, direction matters in projectile or motion in a case. Okay. Next, scalar quantity, speed. Like I am talking about the displacement vector quantity, velocity vector quantity, speed scalar quantity. Okay. Like acceleration, definition is rate of change of velocity with respect to time. Velocity means rate of change of position,
Displacement by
change in displacement by time. Okay, change in displacement by time. Next one, why vectors are essential for kinematics? So kinematics means we'll see about the straight lines as well as the plane. Motion in a straight, yeah, motion in a straight line,
motion and plane.
plane. Okay, in straight lines also, when you are throwing the object towards up or towards down, I am seeing the directions. No, I am calculating the directions also. When I talk about the object is falling, freely falling, gravity positive. If I throw the object towards up, gravity, it is negative. Okay, in both cases it will be helpful. So helpful, distinguish between the distance versus displacement, speed versus velocity, critical for solving two-dimensional problems. Example, projectile or inclined planes. Used in applying equations of motion in vector forms. Okay. Yeah, example, a ball is thrown 20 meter per second at an angle 30 degree to the horizontal. Okay. So in this cases no, like vector component plays a major role. Vector components means some angle has been made. I should take the components in case of x axis, y axis. Okay. Simple thing, if theta like angle is closer to any axis, that is cos theta, away from the axis sin theta. Okay. If I talk about this is my vector and this is the angle which is respect to horizontal. No, with respect to horizontal we'll say, close means horizontal. So this is cos theta, this is sin theta. So with respect to vertical, if I say, with respect to vertical means this is my vertical. So if a question is asked, object is thrown with respect to horizontal, so I should make a diagram like this. If an object is thrown with respect to vertical means I should make a diagram like this. With respect to vertical, here theta makes. So this one will be my cos theta, this is my sin theta. So this is about the components.
Then what if it is 45?
45, they will mention that either it can be with respect to horizontal or with respect to vertical. Cos, sin, both 45s are equal only, no? Okay. So like no, don't worry about the angles. Worry about how, like with respect to what they have given. Okay. Yeah. So components of the vector. This is the thing we have discussed now. So when, yeah, vector can be represented in terms of magnitude and direction. That's one case. Second case is we can write in terms of change in x and change in y. How much it has been changed in x axis, how much it has been changed in y axis. Okay. Yeah. So any vector can be broken down into parts along coordinate axis, x, y, z or anything. Okay. Now these parts are called as components. So components helps in simplify vector calculation. I can take the components in the horizontal direction as well as the vertical directions. I can simplify separately for horizontal, separately for vertical thing. Okay. Okay. So position vector. So to locate the position of a given point in a space or a plane, generally a fixed reference called origin. So origin 0, 0, 0. For a point there is only one position vector. If I consider a point A, there will be only one position vector. If I change that point somewhere else, position vector changes, which means displacement happens. Okay. If I take the pen, if I keep like this is my position, first position. If I take the pen, if I keep in this place, no, position changes. Okay, suppose if I keep exactly at origin 0, 0, 0. If I take if I keep in some space, no, x, y, z. So 0, 0, 0, x, y, z came. So position changes, which means displacement happened. Right now, displaced somewhere. So if I take this is my space, x, y and z. So this is my 0, 0, 0. Okay. Suppose this is my point A. Okay, point A. So this is the position R1 I will take. Okay, R1. This is my x1, y1, z1. Now the position changed, that is B, which is x2, y2, z2. So this is my R2. So position is denoted by R, position vector. So now the position changes, no, this is the position vector. This is my resultant vector. Okay. So here it is displaced, that is S, symbol S. So S is nothing but change in position, no, final minus initial. Change in position is nothing but displacement. So S is displacement, change in position. Okay. Suppose if I talk about the velocity, change in position with respect to time. Displacement by time, no. Displacement is final position minus initial position. So how can I write this one? x2 minus x1, y2 minus y1, z2 minus z1. Okay. Z. So displacement vector, it's a vector that represents the change in object's position from one place to another place. So I have changed the position from one place to another place. Okay, which is denoted by S. Now a force F has a magnitude of 15 Newton. Direction of F is 37 degree from negative x axis towards positive y axis. Now you asked no 45 degree. Okay, now they have given 37 degree, which means like in terms of negative x axis towards positive y axis. How you will take the angle now? Like this. Second quadrant. First write the quadrants, like draw the quadrants. So this is my positive y, positive x, negative x, negative y. So negative x axis towards positive y axis. So initially it was in negative x axis. Now towards positive means with respect to horizontal. I am increasing from x to y. No, I am going from y. I mean x to y. So this is my angle. No. Yes or no? How much? 37 degree. So force is given 15 Newton. Now represent in terms of I and j they have asked. So this one will be my F cos 37. No? Yes, no? Cos 37. What about this one? F sin 37. So this is negative will come because negative direction. It is positive direction. Positive will come. So what is sin 37 and cos 37? I told you no. 3, 4, 5 triangle. Yes or no? 3, 4, 5 triangle. Keep in mind this is 50 degree. So 53 degree. Greater number should be in hypotenuse. 3 should be in opposite direction. Remaining number is 4. So this is 37 degree. Sin 37 opposite by hypotenuse. 3 by 5 no. So here F1 equals to F is 15. Cos 37 5 4 by 5. Cos 37 adjacent no. 4 by 5. 1 sir, 3 sir. Answer is 12. What about this one? F2 15 into 3 by 5. Once, thrice. Answer is F2 equals to 9. Now F equals to F1 plus F2. F1 is in negative direction, minus 12i plus 9j. Okay. Now if I want to find what is the resultant, like magnitude of this, means F equals to under root of minus 12 square plus 9 square. No? Yes, no. What is 12 square? 144. What is 9 square? 81. If I add both of them, how much it will come? 225. 225 under root of 225? 15. Am I getting the answer? Yes, no? Any doubt in this? Okay, we'll stop up to this. We'll continue in the next class. Okay. Yeah. Thank you, guys.